Today I will show you how to extract a stream network from a digital elevation model, whether it's Srtm, Astar, but for this video I'm going to use Srtm. Okay, first you import your elevation model. Okay, and then the next thing you're going to do is we're going to create a personal geodatabase, which I already did. You can just right click personal geodatabase. That's all. So I've created a personal geodatabase. Now the next thing is you go to geoprocessing tool and then you go to environment. Then you, on the workspace, you change the default space to this, as when you navigate to this your geodatabase you created, and then you make it your default location for savings. Alright, when that is done, now the next on the line is if your data is not projected by default. Most of the data downloaded from like this Landsat imageries, Srtm, they come between GCS 1984 because we're in Nigeria, and then Landsat comes in projected coordinate system. So then the first thing you need to do is to project this coordinate system into a project. This one comes under geographic coordinate system, so you project it to projected coordinate system so that you can have a linear unit, but I have done that already. So the next thing you need to do is to you bring up this tool, hydrology. Now we're going to go to locate it in catalog. So the first thing you do is to fill this data so you can make it error free. Using this fill tool, we suck and remove peaks from the digital elevation model. So you input the raster, which is this, and then the output we'll easily just name it fill, and then we okay. So this is done. We could either remove this. Okay, so now the next thing you need to do is to give the bucket direction, that is the direction of the stream, the flow directions. So this direction determines the direction of the flow from one cell to another. So we bring in our field, the field, and then the location, and we name it flow direction. Okay, so now next we are going to use the next tool online, that's the flow accumulation tool. And this tool, it helps in calculating the accumulated flow into each downslope cells in the output raster. So the first we will impute our direction of flow, and it will calculate it using the direction of flow. So let's say IQ at flow or flow add, whichever. Save it, and then it's float. So that's all. Okay, now we're going to create a point, shapefile, or a feature class inside the personal geodatabase we created from the beginning. Now this is to get the mouth location of the river. Okay, so to do that we'll come to where we create our geodatabase. Here it is. So we'll create a future class out of it. Okay, I'll name it Chigun or river mouth, anyone. Then this will be point, and then yeah, we'll finish it. Okay, so we're going to start the editor, and then we'll locate the mouth of the river. So because these ones have so much of point everywhere, so we're going to pick at least a good number of points. Okay, okay. So with this, we'll stop edit and save it. So we'll use this snap PowerPoint to make it flow direction, sorry, flow accumulation, accumulation flow, and this we're gonna name it snap. This will help us to create the watershed. Then next we'll create a watershed. From this, and to create a watershed, we'll bring in our flow direction, and then the snap point value, then name it watershed. Okay, so this is a watershed, and so next we extract it. We'll convert raster using conversion tool from raster to polygon. I didn't spell the raster well. So conversion to raster to polygon. Okay, our raster will be the watershed, and then we can put this is gonna be vector, so we'll name it watershed in vector format. Okay, let's come up with a vector. In this vector we can make here without anything, and then give it a color, and go okay. So this is our vector, So okay, this is our vector. So now next we're going to extract it by mask, so that it will just give us the portion with the portion with the watershed. So we use extract by mask and under special analyst to extract this portion. So here our flow accumulation will be the raster, and then the input will be the watershed, and then we'll name it what? Just put mask. So it will just be the portion where we are having this. So now this is our mask. This is the portion with our watershed. So what we do next now is to extract our streamlines. So in this case we're going to use map algebra using raster calculator to do that. So on the raster calculator, so extracting the streamlines potentials as potential flow lines from a flow accumulation raster using a significant threshold. So now here the threshold value is the ratio of the overland flow area and the single pixel resolution. Now lower threshold value indicate lower overland flow area, and then it will give more streamlines. Then higher threshold value indicate more overland flow area and will give less streamlines. So we use the map algebra now. Alright, so our marks, we use this expression, let's say 500. So we name our location where we want it safe, so we can put it streamlines. Okay, and let's say okay. Now we have our streamlines all over this image, all over the entire extracted area. So these are all the streams line. We're able, based on the ratio, if we use 700, 1000 and above, so the higher the value goes up, the lesser the number of streams line you're going to get. The streamline comes as a polygon, as a raster. So we'll convert this tool again once more, raster to polylines. Okay, raster to polyline under conversion tool. So our input raster will be the streamline, and then the output will be still streamline, but we're going to put it inside our geodatabase. Okay, then okay, so these are the streamlines. So basically this is how you can extract streamlines from a digital elevation model. So we can go on by giving the order of the stream like this one now, but that will be treated in some other tutorials. But right now this is just basic what I want you to know, how you can extract the streamlines from a digital elevation model. And in this tutorial we use Srtm, that's shuttle radar topography mission. So this is what we use for this tutorial. So thank you for watching. Subscribe, like and share. See you in my next tutorial.